So, hello everyone. Today we will do chapter 2 of ninth class of NCERT. Alright, is matter around us pure? Now, what exactly we mean by pure? So, pure is something which is without adulteration. That is, milk is actually a mixture of water, fat, and protein. Alright, and a pure substance consists of single type of particles. Alright, and a substance is a pure single form of matter. Most of the matter around us exists in mixture form. Alright, now, what is a mixture? Mixture are constituted by more than one kind of pure form of matter. Dissolve, that is, if we take example of dissolves NaCl, that is sodium chloride, we'll get sodium and chloride. It is a mixture of sodium and chloride, which we get by the process of evaporation. And the mixture contain more than one pure substance. All right. Now, let's move forward and the type of mixtures. When we talk about the type of mixtures, so here we can see the solution, suspension, and colloidal solution are the following. So what is a solution? Solution is a homogeneous mixture. Homogeneous means a uniform mixture of two or more substance. So this is a type of mixtures we are getting. The type of mixture is the solution. Solution is a homogeneous mixture, which is a uniform mixture of two or more substance. And we also have solid solutions, alloys, and gaseous solutions, air, in a solution where homogeneity at the particle level. All right. Now, what are alloys? Alloys are mixtures of two or more metals or a metal and a non-metal and cannot be separated into their components by physical methods. Brass is mixture of approximately 30% zinc and 70% copper. Now, a solution has solvent and solute. All right, and what these are its component. The components of solution that dissolve the other component in is usually the component present in larger amount is solvent. That means if anything is present at larger quantity, it is solvent, which dissolves the other component, and the component which is present in smaller amount or lesser quantity is known as solute. All right, solute is small and solvent is more. And what is the example? The solution of iodine in alcohol, known as tincture of iodine, has iodine solid as its solute. Solute means smaller one, and alcohol is solvent. That means in tincture of iodine, we have uh, iodine solid as a solute and alcohol as a solvent. Similarly, aerodol drinks like soda, which is made up of carbon dioxide gas, it has CO2 gas as solute and water as a liquid. Now, air is mixed of gas and gas. All right, we have different types of gases in the air. So, the main two constituents of gases are oxygen and nitrogen. So hence oxygen is solute and nitrogen is solvent. What is the property of solution? A solution is homogeneous mixture. The particle of solution are smaller than 1 nanometer, that is 10 to the power minus 9 meter in diameter, and they cannot scatter a beam of light passing through the solution. So the path of light is not visible in solution. The solute particles cannot be separated from mixture by process of filtration, and solution is stable. Now, if we talk about the concentration of solution, now concentration depends upon the amount of solute present in the solution. It is called a dilute, concentrated, or saturated solution. Dilute and concentrated are the comparative term. I hope it is understandable. So, if we talk about the concentration of solution, it is the amount of solute present in a solution makes a solution dilute, concentrated, or saturated solution. All right, and the dilute are the concentrated are comparative terms. The amount of salt and sugar or barium chloride that can be dissolved in water at a given temperature is small. Well, a solution that has dissolved as much solute as it is capable of dissolving, it is said to be saturated solution. Means it has completely dissolved all of its solute. That means, uh, and it is not capable of adding more solute to the solution. At that time, the solution which we get is saturated solution. We have no more solute can be dissolved in solution at a given temperature. It is known as saturated solution. And the amount of solute present in the saturated solution at the temperature is called the solubility. That is, the solute present in the saturated solution at a particular temperature is called the solubility. And if the amount of solute containing it a solution is less saturated level, it is known as unsaturated solution. Means if the amount of solute contained in a solution is less than the saturation level. What is saturation level means? No more further solutes can be added in a solution. At that time, if there is some kind of deficiency in solute in the solution, at that time, that solution is known as unsaturated solution. And the different substance is a given solvent have different solubility at the same temperature. Means if there are different substances which are in a given solvent, it will have the different solubility in the given temperature, and the concentration of solution is the amount, that is mass or volume of solute present in the given amount, that is mass or volume of the solution. That means solute by solution into 100. Mass of solute by mass of solution into 100, that is the mass by mass percentage of solution. So if we want to find out the concentration of solution, we will make a ratio of mass of solute and mass of solution, and we will further multiply it with 100 so that it can give it in the percentage form. And now mass by volume percentage of a solution. What can be mass by volume percentage of solution? Mass of solute by volume of solution into 100. That means we have the solute and solvent again, and earlier also we had the solute and solvent, and every time we'll be having solute and solvent, sorry, solute and solution. Both time, every time will be solute and solution. The first time was the mass by mass percentage of solution. All right. Another one is mass by volume percentage of solution. Mass by volume means the solute will be having mass and the solution will be having the volume. And then we have the volume by volume percentage of solution, in which both volume of solvent, solute as well as the solution into 100 will be done. All right. Now we can use this formula and get the mass percentage like this. In 11.1 percentage we got. Now what is the suspension? Now suspension is a non-homogeneous system. That means it is not homogeneous. Homogeneous means uniform. That means in suspension it is not uniform. And solids are disappeared in liquid, dispersed in liquid, are called suspension. When solid is dispersed in liquid, it is known as suspension. And suspension is a heterogeneous mixture, that is a non-uniform mixture, and with the solute particles do not dissolve but remain suspended throughout the bulk of the medium. That means they not get dissolved completely, and they remain suspended throughout the bulk of medium, and they are also visible through the naked eye. Now, what is the property of the suspension? Firstly, it is a heterogeneous mixture. That means it is non-uniform. We can see somewhere more particles are there, somewhere less particles are there. Some are more mixed, some are less mixed, and they can be seen through naked eyes. And they scatter beam of light passing through it and make the path visible. All right, and the solute particles settle down when a suspension is left undisturbed, and the suspension is unstable. The separated from mixture by the process of filtration. We can separate it by the filtration, and when the particles settle down, the suspension breaks and it does not scatter the light anymore. But that means when the particles get suspended in the bottom of the solution of the container, at that time the suspended particles cannot give the beam of light. Now if we talk about the colloidal solution, now the particles of colloidal are uniformly spread throughout the solution. That means it can be so what, homogeneous type of mixture. That means they are uniformly spread throughout the solution due to the relatively smaller size of particle as compared to that of a suspension. The mixture appear to be homogeneous. That means it is a homogeneous mixture, but actually a colloidal solution is a heterogeneous mixture. See, here is when the colloidal plays its game. Now the solution, the ordinary solution was homogeneous in nature. The suspension solution is a heterogeneous in nature, And the colloidal solution may look like uniform or a homogeneous solution, but in actually it is a heterogeneous solution. All right, that means it is non-uniform, though it looks uniform. Now let's move forward with it. But actually, colloidal solution is a heterogeneous mixture. Why? Because small size of colloidal particles cannot be seen through the naked eyes. That means particles are not uniformly mixed. They cannot be seen through naked eyes, but they are not possibly mixed. And this scattered off beam of light is known as Tyndall effect. All right, we will see the diagram later on what is Tyndall effect. And Tyndall was given by the scientist. All right, so the name came after it. And the Tyndall effect can be observed when fine beam of light enters a room through a small hole, and due to scattering of light by the particles of dust and smoke in the area. All right, this is the Tyndall effect which we see. So this type of solution is given by the colloidal solution. So we see that the solution is the only solution. The solution is the homogeneous solution, whereas the suspension as the colloidal solution both are the heterogeneous solution. As the colloidal solution may seem like a uniform solution, but it is actually a heterogeneous solution. Now, the Tyndall effect can be observed when sunlight passes through the canopy of dense forest, all right, and mist contain the tiny droplets of water which act as a particle of colloidal dispense in air. And so, hence, what is the properties of colloidal solution? The colloidal is a heterogeneous mixture. It is too small to be seen by the naked eyes, and the colloidal are big enough to scatter a beam of light passing through it, and it makes its path visible. That means we cannot see them, but they give the beam of light by giving the path, and they do not settle down when left undisturbed. That means when our the suspension solution was seen earlier. In suspension solution, if we left the particles undisturbed, it gets settled down on the bottom of the solution. But in the colloidal solution, they don't does that. That means the colloidal solution is quite stable, while as the suspension solution was not stable, and they cannot be separated from the mixture by process of filtration. That means we cannot separate it by the filtration process. So how do we separate them? By centrifugation. Now centrifugation is something which is used to separate the colloidal particles. We will learn more on it. And the components of colloidal solution are the disperse phase and the dispersion medium. The solute-like components or the dispersed particles in a colloidal forms the dispersed phase, and the component in which the dispersed phase is suspended is known as the dispersed medium. So dispersed medium is nothing but the whole phase in which the suspension is taking place. It is known as the dispersed medium, the medium at which the complete dispension is being taking place. The dispersed phase is taking place. And what is the dispersed phase? It is a solute-like component. That is the little amount it is shown. The solute-like component or the dispersed particle in a colloidal form the dispersal phase. All right. So here we get the dispersion medium. That means the component of colloidal solution is the dispersed phase and dispersed medium. Dispersed phase is the nothing but the solvent. Sorry, the solute of the solution, whereas the dispersed medium is the solvent or complete solution of the area. Now, here it is the dispersed phase of liquid gas. Dispersed medium is the gas. We see the type of aerosol. An example are fog, cloud, mist. These are the examples of aerosol. And dispersed phase we have liquid, and dispersed medium we have gas. That means liquid is in small quantity and gas is in large quantity. And now solid is in a small quantity and gas is again in a large quantity. It is again aerosol, the smoke, automobile exhaust. Now if gas is in small quantity and liquid is in high quantity, it forms the foam. All right, that is the shaving cream, shaving foam which we use. If both are liquid, we see the emulsion, that is the milk and face cream. Now the solid and liquid, we see the solution, that is milk of magnesia and mud. If gas is small quantity, solid has high quantity, it again creates a form, that is foam, rubber, sponge, pumice. All right. Now liquid and solid, that means liquid in small quantity and solid is in high quality. At that time, you'll see gel, that is jelly, shea butter. All right. And if the solid is in large quantity, sorry, smaller quantity, and solid is again in large quantity, we'll see the solid solution, that is the gemstone milky gas. How do we separate the components of mixture? The heterogeneous mixture can be separated into respectively constrained by the simple physical methods of hand picking and sewing and filtration. That means the non-uniform solutions, which are heterogeneous in nature, can be done filtration by the can be separated by the hand picking, sieving, as well as the filtration. And how do we obtain the colored component dye from blue ink? Through the process of evaporation. All right. And how we can separate the volatile component solvent from its non-volatile solute by method of evaporation. How do we separate cream from milk? It is again the process of centrifugation. All right, which we have discussed earlier in the homogeneous, that is the colloidal solution. The solid particles in liquid are very small and are passed through a filter paper. That means the solid particles in a liquid are very small and pass through a filter paper. From such particles, the filtration technique cannot be used for the separation, and such mixtures are separated by the centrifugation, as I have told already. And the principle is that the denser particles are the force of the bottom, and the lighter particles stayed at the top when spun rapidly. Means when you are spinning the rapidly through the process of centrifugation, the heavier particles will get suspended in the bottom, while the lighter particles will stay on the upside. And what are the application? And it is used in diagnostic laboratory for the blood and urine test. That means in blood and urine test, this system, that is the centrifugation, is used. Along with that, it is also used in dairies for the home to separate butter from cream. Along with that, we also use the same thing in the washing machines also, to squeeze out the water from the wet clothes. How do we separate mixture of two immensible liquids? All right. So to separate mixture of oil and water, that means these are two impencil liquids, we can use the same techniques to separate the mixture of oil and water, extract the iron from its ore, and lighter slag is removed from the top through the method of leave to molten iron at the bottom in the furnace. That means in furnace, what we can do the extraction of iron from its ore, and the lighter slag is removed from the top by this method, and leave the molten iron at the bottom. That means the molten iron is in the bottom, and the lighter slag is being taken from the ore, that means from the top. Now the principle is that the insoluble liquid separated out in layer depends on the density. So the principle is emulsification liquid separates out in layer depends upon its density as well. All right. Now let's move forward. Again, the dye in black ink in a single color. Usually, a dye is a mixture of two or more color. The colored component that is more soluble in water rises faster, and in this way, color gets separated. And the process of separation of component of a mixture is known as chromatography. We have known about the chromatography, and this technique was first used in separation of colors. And chromatography is the technique used by the separation of those solutes that dissolve in the same solvent. And what is the application of it? The colors in a dye, pigments from natural colors, and drugs from the blood. How do we separate a mixture of two miscible liquid? Now, this method is known as distillation. We have to make notes on it. For emulsification liquids, we use the process of distillation, and its separation of component of a mixture containing two miscible liquids that boils without a decomposition and has a sufficient differences in the boiling point. To separate the mixture of two or more the miscible liquids from which the differences is boiling point is less than 25 K, fraction distillation process is used. That means if two liquids are used and their boiling points have a difference of less than 25 K, that is Kelvin, at that time, the distillation method is used, and the separation of different gases from air, different factors from petroleum product is same. And simple fractional column is a tube packed with glass bead, and the beads provided surface from the vapor. to cool and condense rapidly. This is what we are talking about. Now, obtaining different gases from air. How do we obtain gases? Now, air is a homogeneous mixture and can be separated into component by fractional distillation. That means it is a homogeneous mixture, so it can be separated by the fraction distillation. That means we have air. We will compress and cool by increasing the pressure and decreasing the temperature. In this way, we will get a liquid air, and which will allow to warm up slowly in a fraction distillation column, and gases get separated at a different heights. All right, so in this way we'll get the percentage air by volume: 20.9% for oxygen, argon is 0.9%, and nitrogen is 78.1%. And oxygen gas from air is also used by this method, that is the fraction distillation, and they separate out the other gases present in the air, and air is compressed by increasing the pressure and then cooling it down by decreasing the temperature to get the liquid air. And the liquid air is allowed to warm up slowly in a fraction distillation column, and where gases get separated at a different height depends upon the boiling point. Now this is what we are doing thing. We are sending the air in, then through this air the pressure is increased, and then it comes out as a hot air. And here we have the freezing cold water which is being getting warm up and getting the water out, and this hot air is later converted into the cold air, and then this pass through the separator in which carbon dioxide is taken out as a dry ice, and the water and the cooler air goes to the liquid air. That means it is condensed slowly. And here we also see the nitrogen gas and argon is going out through the fraction distillation column, whereas the liquid oxygen is being stored here. So how to obtain a pure copper sulfate from an impure sample? All right. Now, crystallization is the method used for the purifying solids. To remove the impurities, crystallization is used. Separate a pure solid in the form of other crystals for solution. Crystallization technique is better than simple evaporation technique, and some solid decomposition is can be seen, and some impurities may remain in the dissolve in the solution even after the filtration. Hence, crystallization is better than the evaporation. Now, application: purification of salt that we get from seawater is done by the crystallization, and separation of crystal of alum Fitkery from impure samples is also done through the crystallization process. And drinking water is supplied from work from, as we have discussed. This is the reservoir through which it goes to the sedimentary tank where to allow the solids to settle, and then we have a loading tank to sediment the suspended amplitudes and impurities, and we have the filtration tank where different types of components are present, and from there it is sent for chlorination, where we get the water, the pure water, purified water. And the physical and chemical changes: now we have discussed that the color, hardness, rigidity, fluidity, density, melting point, boiling point, these are the physical properties, and these are interconventional of the interconversion of the states is the physical changes, because of these change occurring without a change in the composition and a chance in the chemical nature of substance, and they are chemically the same. Water and cooking oil are liquid, but their chemical characters are different in odor as well as the inflammability. And burning is a chemical change. Once one substance reach with the another to undergo the changes in a chemical composition. And chemical changes is also known as the chemical reaction. The burning of candle is both physical as well as the chemical reaction taking place. Now we will see the type of pure substances, whether they are elements or compounds. If we talk about the elements, it was first used in 1661 as a word by Robert Boyle, and the elements can be normally divided into the metals and non-metals as well as the metalloids. So we have divided the elements into metals, non-metals, and metalloids. As the name suggests, metals are metals, non-metals are metals, and metalloids are something which shows the properties of both metal and as well as non-metal. Now the metals usually show some of these following properties. Metals are lustrous, they shine, they are usually silver gray or golden yellow color, they conduct heat and electricity. They are ductile in nature, that means they can be drawn into wire. They are malleable, that they can be hammered into thin sheets, and they are as well as sonorous in nature. They make ringing sound when they are hit. So, gold, silver, copper, iron, iodine, sodium, potassium, these are some examples of metals. We have mercury is the only metal which is liquid at the room temperature. Now, if we talk about the non-metal, the properties which can be shown are display a variety of colors. They are poor conductors of heat and electricity, and they are non-lustrous, sonorous, or malleable. All right. Now, what are the examples of non-metals are hydrogen, oxygen, iodine, carbon, that is coal and coke, the bromine, chlorine, etc. are some examples which can be used between those metals and non-metals, and these are metalloids. Examples are boron, silicon, and germanium, etc. So, boron, silicon, germanium are the metalloids. Metalloids means they show the characteristic of the properties of intermediate level of both metal as well as the non-metals. All right, and we have the 92 elements are naturally occurring and the rest are man-made. That means only 92 elements are naturally occurring. Majority of the elements are solid. 11 elements are in gaseous states at the room temperature. That means these elements are in the gaseous state. Which elements are we are talking about? The hydrogen, helium, neon, argon, krypton, xenon, radon, fluorine, chlorine, nitrogen, as well as the oxygen. And two elements are liquid at the room temperature. These are mercury and bromine. Mercury and bromine are the Mercury and bromine are the two elements which are liquid at the room temperature. Now, elements like gallium and cesium becomes liquid at the room temperature, slightly above the room temperature. Means, if we have more temperature above the room temperature, at that time the gallium and cesium will be become liquid in the room temperature. Now here we have used another example. 5 gram of iron filling along with the 3 grams of sulfur powder in a china dish. We have mixed them well, iron filling and sulfur powder. Now group 1 is mixing it only, and group 2 is mixing, and then we it is also heating it. Thereafter they are removing the fumes, and they let it to mix cool. Then check for the magnesium in the then we will check for the magnesium in the material bring a magnet. All right, check for the magnesium in the material bringing magnet, and add carbon disulfate to one part of the material obtained. Now stir well and filter. That means we will add carbon disulfide to one of the material obtained, stir well and filter. Add dilute sulfuric acid or dilute hydrochloric acid to a other place. Now the difference between mixture and compounds have been done. The elements or the compound just mixed together to form a mixture are no new compound in form. That is, in mixture there is no new compound is formed, and they are just mixed it well. And the mixture are variable components. A mixture shows that the properties of constituent substance. A mixture shows the properties of the constituent substance, and the constituents can be separated easily through the physical methods. Now, when it comes to compounds, compounds are usually forming a new compounds. All right, and the composition of each new substance is always fixed, and the new substance has totally different properties, and the constituents can be separated only by the chemical as well as the electrochemical reactions. Uh, Now, a gas obtained by group 1, by mixing it we get hydrogen. It is a colorless. It is a colorless as well as the it was colorless and odorless and combustible gas. Combustion test for the hydrogen in the class, and the gas obtained by group 2 is hydrogen sulfide. That means after burning it up, after we heat it up, we get the hydrogen sulfide, and it is a colorless gas with the smell of rotten eggs. All right, and we showed different properties through the starting materials were the same, and group 1 has carried out the activity involving a physical change, whereas in the group 2 chemical change is happening place. That means in group 1 we are seeing a physical change, and group 2 we are seeing a chemical change. The material obtained by group 1 is the mixture of two substances, and the substance given elements are iron and sulfur. All right, material obtained by group 2 is a compound, and heating the two elements strongly, we get the compound, which has totally different properties compared to the combining element. Now we have this matter, which is solid, liquid, and gas, further divided into pure substance and the mixture. In pure substance, we have the element and compounds, and in mixtures, we have homogeneous as well as the heterogeneous mixtures. Now, in pure substances, when it comes to elements, they cannot be broken down into simpler substance because they are already broken down in elements. Now, in compounds, they have fixed composition and can be broken down into elements by chemical or electrochemical reactions. Examples of elements are copper, oxygen, iron, hydrogen, and mercury. And examples of compounds are water, methane, sugar, salt, and etc. Now, if we come about the mixtures, we have the homogeneous, which is the uniform mixtures, and we have the heterogeneous, which are non-uniform mixtures. We have uniform composition, homogeneous, and heterogeneous are non-uniform composition. An example of homogeneous mixtures are the sugar in water, salt in water, sulfur and carbon disulfide, water and alcohol at extra. And for example, sand and salt, sugar and salt, water and oil. So these are the examples of heterogeneous mixture. They are not uniform, and homogeneous mixture are uniform. And the solution is homogeneous. A solution is a homogeneous mixture of two or more substances. The major component of solution is called the solvent, and the minor one is known as the solute. The concentration of solution is the amount of solute present as per the unit volume or per unit mass of solution. All right. The materials that are insoluble in a solvent and have particles that are visible to naked eyes forms a suspension. A suspension is heterogeneous mixture. The materials that are insoluble in solvent and have particles that are visible to naked eyes form a suspension, and the suspension is heterogeneous mixture. The colloids are the colloidals. We have again talked about it. Let me just remind it again. The materials that are insoluble in solvents, have a participle, are visible at naked eyes, are known as forms of suspension, and the suspension is homogeneous mixture. All right. The colloidal are the heterogeneous mixture, which has particle size too small, which can be seen from naked eyes, but cold enough to scatter light. The colloidal is using industry and daily life, and the packets are called the dispersed phase of medium, which is disturbed is called the dispersed medium. All right, we have the dispersed phase and dispersed medium. In a colloidal solution, the solutes are known as dispersed phase, and the solvent is known as the dispersed medium, and together they make the dispersed solution. The pure substances can be elements of compounds, and elements is a form of water matter that cannot be broken down by chemical reaction into simpler substances. The compound is a substance compounded of two or more different types of elements chemically combined in a fixed posture proportion. All right, that means a compound is something which is composed of two or more different types of elements chemically combined into to the fixed proportion, while a pure substance is divided into elements and compound. Element is something formed by matter which can be broken down into chemical substance. The properties of compound are different from its constituent elements. Mixture shows the property of its constituent elements or the compounds. Hence, we have completed this chapter, and I will continue the chapters of the NCRTs, starting with science, and then we'll go through history, geography, polity. That is M. Lakshmikant. So, thank you everyone for listening, and Jai Hind.